Continue day 2 of 8.5 talking about slope. There are particular lines that have to do with, that have some concepts of slope, which would be, the first ones are going to be parallel lines. Parallel lines, when you learned about parallel lines before, you know that those are lines that will never ever cross and are always the same distance apart. As you see on the grid here, we have parallel lines. What now we can use for description for parallel lines is that parallel lines have the same slope. In order for them to stay the same distance apart, they need to have the same slope. Now you also notice they cannot have the same y-intercept. Otherwise they would be the exact same line. So if I looked at the slope of, I look at the slope of this line. Let's put it at 6, 0, 6, and then another intersecting point, I guess I don't have another point here, would be, let's try for right here. So my slope then for this line would be rise 1, 2, 3, 4, and run 2. Now if I do the same thing here, my y-intercept for this is at a negative 6. And so its slope should also be a rise 1, 2, 3, 4, and run 2. Okay, so they both had a slope of 4 over 2, which means their slope is reduced to 2. So I could have also put, this one didn't look quite as obvious. And this one here, if I went up 2 and ran 1, there you go. Whoops. There you go. Now another type of line is perpendicular lines. You're going to notice on perpendicular lines, they will cross, they will intersect. If this was my original line here, that you will notice that my perpendicular line needs to have the opposite slope. So this line has a positive slope. That means that this line will need to have a negative slope. We know the slope of a perpendicular line because it is opposite. So we have a positive 2 here, we'll have a negative here, and it is also the reciprocal. So 2 over 1, if I change it to the reciprocal, it is 1 over 2. So a positive 2 over 1 for this slope, and the perpendicular line would have the opposite reciprocal as a negative slope, and that would be 1/2. So when we're given a line to begin with, so my line is y equals negative 4/3 x minus 6, linear equation already in slope-intercept form. I'm going to graph it by beginning with the b. The b is at negative 6. My slope is going to be a negative 4, 3. Remember, I could go down 4 or rise 4. 1, 2, 3, 4. And run positively. 1, 2, 3. Or if your graph doesn't allow you to go that way, you could also, red here, you could rise positively. 1, 2, 3, 4. And then run negatively. 1, 2, 3. Now let's go ahead and graph this line. So, whoops. And this would be the graph line for negative 4/3 x minus 6. Now, if I wanted another line parallel to this one, I would have to make sure that it has the same slope. So this line would also have to have a negative 4/3 x. Now for this particular line, the y-intercept is at 8. So I could write this equation, and you don't need to do this, but I think this makes it a little bit more understandable. I could write the equation to this next line here, my parallel line, as y, maybe I can, y equals, I know the slope is the same, it's the parallel line, negative 4/3, and then I see the y-intercept is at 8, and it's a positive 8, so that's my b term there. So there's the equation to my parallel line. It's going to have the same slope, negative 4/3, and then the y-intercept, or where this line crosses the y-axis, is at a positive 8. Now, if I needed to know a perpendicular line, I would, let's give me a different color here, I would know that the perpendicular line needs to have an opposite slope. So a perpendicular line I'm going to do is not going to have a negative slope, it's going to have a positive, and then I'm going to do the reciprocal. So a perpendicular line, I'll just sketch one in here real quick. Of course, it didn't quite make it through we're going to say 1 through 4. So the perpendicular line here would be, the equation for that would be y equals, and I'm going to do a positive because the first slope was negative, and the reciprocal would make it 3/4 x, and it's going to cross this time at a negative 4 for the y-intercept. So that's how I can write the equation of a line if I have an original line. I can tell about the slope of a parallel or a perpendicular line just by that original line. I would need a graph to see where the y-intercept is at this point. So let's review that one more time. So finding the slope of a line that has the given relationship to the line with the equation. So the first thing I'm going to do for this equation is I need to write it in slope-intercept form. So I need to get my y by itself. So I'm going to subtract 4x, subtract 4x. This is what we were doing in an earlier lesson. I'm going to end up with 3y, and I'm probably going to have to scoot that over because I'm not going to have enough room. It's a little mini magic here. Oops. Maybe. Actually, I think it's going to be easier just to rewrite. Okay. So I'm going to rewrite this as 3y, oops, get back on my pencil, 3y equals, remember I'm going to put my x term first, and now you should understand why we were practicing that, negative 4x minus 18. Now I need to solve for a single y, so I'm going to divide both sides by 3. So I'm going to have that y equals, for my first equation, negative 4/3 x, and then negative 16 divided by 3 would be a negative 6. Now my equation's in slope-intercept form. If I was asked what the slope of a line that is parallel would be, we know that that slope has to be the same. So the slope would be a negative 4/3. If I'm asked to describe the slope of a perpendicular line to this line, I would look at it and it would be the opposite, so it's going to be positive, and then the reciprocal. So that would be a positive 3/4. And that is the concept of slopes of parallel lines and perpendicular lines. And that will finish day 2.